So, hello everybody and welcome to this Operations Research video lecture. We are in chapter 5 and we are solving the more deep bakery problem or revisiting it. And in the last video lecture we ended up here, so we are using Octave and we run the more deep revisited, got the solution, and everything seems to work fine. So what is rest here is to try to understand how and why does it work. And for this, it's explained, the code is there in the lecture notes. Let me show it to you. That's the wrong window, that's the correct window. So it's here, 5.7 solution on page 6. And there it's given, there is the listing of this code, and after that there are some explanation how it works. So I will do the same, basically give this explanation here of the code by using the code in the Octave window here. So a good way to actually make the code and also review it is to open the editor tab here, and here I open the respective M file, more deep underscore revisited.m. It's here. Okay, so maybe the font is slightly, well, maybe you can see, but I have old eyes, so I make the font bigger. And then of course I lose the end of the lines, so now I also make this sidebar smaller. Is this enough? It's obviously not completely enough, so let me make my face smaller and adjust here, and again here. Okay, now I have it here. So let me go through this more or less line by line. So first, again, as always, we have the kind of title block. So I have a comment signs, and actually I haven't told you this before, but this is exactly 80 characters. You can see here it's line 1, column 80, and you can probably see here this dim gray line. It's a kind of, for historical reasons, some people prefer that the code is 80 characters wide at most. And some other people think that this is, people who think that that should be the case are dinosaurs. Okay, so I'm being a bit dinosaur in this course. I recommend to you that maybe, okay, you can follow the 80 characters wide code as I do, or if you for some reason wish to do something different, then why not? Okay, so here I have in these comment signs more deep bakery revisited, and also gave a reference that this is problem 5.5 from linear programming with Spice. So this is just a title so that someone reading this M file would immediately get the idea what and why this is. Then, as usual, we have the data section. So the idea is that we give the data independently, so that what happens next is not dependent on the data, and if we change the data, we can change it here and the rest would work just fine. Hopefully, sometimes it will, sometimes it doesn't. Alright, let's give the data. So what is the data? The data is of course C. That's the objective function, is defined by the vector C, where we have prices for the cakes. Then we have the technology matrix. Technology matrix A, that tells us how these nutrients, these powders, are transformed into cakes. And the third, what we had, is the limit or the available nutrients. So how many nutrients we have. So these C, A, and B have to be given here in the data section. And now I give them slightly different way than in the more deep bakery problem. The reason why I do this differently is basically just for fun and just to show you that you can do this differently also. Of course, there's no need to do any of this. We could just use the more deep.m. We have already solved this problem. So what I do here, I actually give this C vector element-wise. So this is a kind of nice thing about Octave, that it's very dynamic. I mean, in most programming languages, you have to first tell that object is, for example, a three-dimensional vector. In Octave, you don't have to do this. I can just say that C is something which and it is its first element, so C1 in the parentheses will be 120. Let me actually demonstrate how this goes. So Control L, I clear the screen. So C1 is, okay, it was 120. And this is not what I expected and not what should be there. Okay, the reason what happened here now was it was actually good that this happened, so I can explain you something that I've forgotten. So I had already run the file modDip revisited, and in doing so, you can see here the workspace, there are some variables that are defined. These variables are defined because the script file modDip underscore revisited defined them. And now I actually want to clear the workspace. So this happens by command surprise surprise clear. And to be completely sure, I ask it to clear all. Now this workspace here is empty. I can also ask who is there, so no one is there. So now it's cleared. Okay, Control L, this clears screen. That's a different clear, of course. And now let me say C1 will be 120. So what happened, it defined C1, so a vector that has first element 120, and this basically, so this is a vector of length 1, we call them also numbers, so it just says that C is 120. Let me try something slightly weird. Let me say that C5, so C's fifth element, let make it, I don't know, 42, why not? Whoop. Something strange happened. So now C is a vector that has 5 elements, and this is the kind of maybe weird but extremely convenient working of Octave. So I can actually build the vector dynamically. So C1 120, okay, it's just the first element, so what do you need? You need a vector of one element that is a number, so that number will be C and it's 120. Then I say that C5, so the fifth element should be 42. Now at this point C only has one element. So what will Octave do? It will actually build up a long enough vector so that it will have fifth element. And the fifth element indeed has a 42. The first element already is defined to be 120, and then in the between it has to fill the elements with some values. And I mean, maybe not completely logical, but convenient and natural is that if you have not given the values, then let's put them zeros. Why not? Okay, this is the kind of idea I am now using in this file. So I define C1, C2 and C3 separately. Note the semicolons here in the end, so to prevent Octave from echoing back what happens there. And then in the notes, so double comment mark here, so that is a permanent comment. I tell them that there are prices for our traders, prices for Corin, and prices for Harkonnen. Okay. And if you look at the nutrients here, B1, B2, B3, B4, B5, it's the same thing. And here I've noted what are the units, so kilograms, 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 liters, and grams. And then I do the unit changes from kilograms to grams, liters to milliliters, and grams to milliliters in this B. So this is, let me go to the notes, and this is not the correct, this one is the correct. So this is related to B here, so 1000 times have to be multiplied to get the correct units. So it happens here. All right. What I did now, I actually skipped the A matrix. That was on purpose because this is slightly more complicated, but this is maybe a convenient way of doing it. I mean, given this as a C1, C2, C3, or as a vector, so why don't we open the mod dip for comparison? So here is the mod dip, the same problem, but with yeah, slightly different way of representing or giving the data. So here the C is given as a vector, and this makes it a column vector, and here B is given as a vector here, make it a column vector, and then the unit change of 1000 is done like this. And then the matrix is given in the way that matrices are given usually. So with C and B, it's probably there's probably no much difference given in the vector or element wise, but this could be actually very convenient to give the matrix row wise, especially if you want to add or remove rows. I don't know, maybe not. So what happens here? So this, if you remember our bullet or column notation, this line here tells us that that the first line of matrix A will be this one. This tells that the second line has to be this one, and so on. So I think it's relatively clear what happens here if you remember the column notation. So of course this stuff, what happens here, is exactly the same stuff that happens here. So it's somehow a matter of taste which way you want to do it. Okay, so that's maybe the main difference between these two files. Here is the solution with GLPK. So here it's a very minor difference. So this is of course the 39. This is the line with the beef. This is where the solution happens. So C, A, and B in a GLPK, it always starts like that. Then we have the so-called a priori upper and lower bounds, which in our case will be the standard ones. So then we pass just empty matrices there. So the lower bounds will be the sign constraints, and then there are no upper bounds. And by default, the lower bounds are really the sign constraints, so zeros, and the upper bounds are plus infinite, that is there are none. Well, then comes the constraint type C type, gives us whether these inequalities are upper or lower bounds, or equalities or something else. And in this case, they are all upper bounds. So, something like this. I suppose the camera doesn't switch left and right, so that probably went correctly. So that's U, upper bound. So let me really, let's see, where do I have? It's here. So the upper bound means these. So they are all upper bounds, and there are 4 of them. So this should be 4 times the U character in strings. And finally there is the variable type, so that 3 variables x1, x2 and x3, and we in this course we pretty much always assume that everything is continuous, so that's a C. It could be in this case that only whole cakes can be solved, and then that would mean that the characters are not continuous but integers. So then you would use I, capital I, instead of capital C, I for integer. Alright, so about this C-type and V-type, you see a slight difference with this revisited version. In the original version, it's a one-liner. So all these parameters are given in one line. So constraint type here, for upper bounds, and variable type here, 3 continuous variables. In this more deep revisited, I decided to give them in 3 lines. So I define a variable that's a string, that is the C-type, which is just what it should be, and also a string variable V-type, that is again what it should be. So yeah, and then I pass these variables here. So these 3 lines that I have here is basically the same as the one line here. So you can define the variables first and then pass them here, or just pass them here directly without this intermediate definition. And finally, yes, remember this -1 always. So here, this is the sense of this problem, whether it's a maximization or minimization. Octave assumes minimization as default. So if this is not there, then Octave tries to minimize this, or if this one the same thing, so we put there -1. This means that we want to maximize. And that's basically end of the code. That's how it works. But everything here is ending with semicolon, so nothing would be printed. Of course, the variables would be defined. But then in the end we want the output, so x_max and z_max in its lines just output these variables. So remember, Octave works this way, that if you just type the name of the variable, then Octave will echo back that the variable has whatever value it has. And then we have the final section that is typically a good idea to have, is a test result. So this is a commented section. What happened here is basically I just took the command window and I ran the modip revisited, and then there is some kind of problem. This probably is I did here something that was why does it say that? Okay, let's see. Is there a mistake? Maybe this is also informative to look what happened. A must be 5 by 5, not. So it says that for some reason the A is not correct dimension. It should be 5 by 5, not 5 by 3. Why should it be 5 by 5? Okay, let's have a break here and I try to figure out what went wrong. Sorry about that, but maybe this is informative. See you soon.